Welcome to our comprehensive guide on Splunk Summary Indexing. The summary command is a powerful feature that transforms search results into pre-computed summaries stored in dedicated indexes. This technique provides lightning-fast query performance and significantly reduces computational overhead. By creating summary indexes, you can accelerate your searches and improve the overall efficiency of your Splunk environment. Summary indexing is particularly valuable when dealing with large volumes of historical data that need to be analyzed frequently. Summary indexing offers two major advantages for Splunk administrators and analysts. First, it delivers a tremendous performance boost, reducing query execution time by up to 168 times for historical data analysis through pre-computed summaries. This dramatic improvement occurs because Splunk doesn't need to process raw data repeatedly for the same calculations. Second, summary indexing provides exceptional resource efficiency by minimizing storage requirements and optimizing infrastructure workload. The smaller summary datasets consume significantly less disk space compared to raw logs while still providing the analytical insights you need. Implementing summary indexing follows a structured four-step workflow. Step 1 involves creating a dedicated summary index with proper retention policies configured according to your organizational needs. Step 2 focuses on designing the aggregation query using specialized commands like sistats and sitimechart. These commands are specifically optimized for summary indexing operations. Step 3 requires setting up automated execution through scheduled reports with appropriate time intervals to ensure your summary data stays current. Finally, Step 4 involves enabling summary indexing in your report settings to activate the automated data collection process. Following established best practices ensures successful summary indexing implementation. Clear naming conventions are essential for maintaining organization as your environment grows. Use descriptive names for both summary indexes and saved searches to make management easier. Optimal scheduling is crucial. Ensure your searches run more frequently than queries against the summary index to keep data fresh and accurate. Leverage specialized SI commands like sistats and sitimechart for statistically accurate summary results that can be properly reaggregated later. Finally, configure different retention policies where summaries are kept longer than raw data to optimize storage while maintaining historical visibility. Two common issues can occur during summary indexing implementation. The first issue is when your summary index is not populating with data, which typically happens when trying to use standard commands with custom indexes. The solution is to use the collect command instead of SI commands when working with custom summary indexes. The second common issue involves data gaps, where missing data periods occur because search runtime exceeds the scheduled interval. This can be resolved by running the fill_summary_index.py script to backfill any missing time periods and ensure data continuity. 4 essential commands form the foundation of summary indexing operations. The sistats command generates statistical aggregations specifically optimized for summary indexing, such as counting events by host and source type. The sitimechart command creates time-based charts with summary index compatibility, perfect for generating hourly or daily trend data. The collect command stores search results directly in custom summary indexes, providing flexibility in data storage. Finally, the summary command allows you to search against existing summary index data efficiently, enabling fast retrieval of pre-computed results for dashboards and reports. Here's a practical example of a basic summary search for weblog analysis. The search targets weblogs from the previous day, using earliest minus 1 day at day and latest at day for precise time boundaries. The sistats command aggregates the data by counting total requests and calculating average response time, grouped by host and status fields. This approach transforms potentially millions of individual weblog events into manageable summary statistics that can be quickly retrieved for dashboard displays or further analysis. The resulting summary data maintains statistical accuracy while dramatically reducing the volume of data that needs to be processed for subsequent queries. This example demonstrates time-based summary indexing for security log analysis. The search examines security logs from the past 24 hours, using bin_time with span equals 1 hour to create hourly buckets. The sitimechart command generates hourly summaries counting total events and calculating distinct source IP addresses, grouped by action type. This time-based approach is ideal for monitoring security trends and creating time series visualizations. The hourly granularity provides detailed trend analysis, while keeping summary data volumes manageable for long-term storage and rapid dashboard updates. Once summary data is created, querying it becomes straightforward using standard SPL commands. This example shows how to search a summary index using index equals summary with the source field identifying the specific summary report. The timechart command operates on the pre-computed summary fields like total requests and average response time to create daily trend visualizations. Notice how the search leverages existing summary fields rather than recalculating statistics from raw events. This approach provides exceptional query performance because Splunk processes only the small summary dataset rather than scanning through potentially terabytes of original log data. Let's summarize the key takeaways from our summary indexing discussion. Performance acceleration is the primary benefit, with summary indexing reducing search time by 168 times for large historical datasets. SI commands are essential for maintaining statistical accuracy. Always use sistats and sitimechart for reaggregation capabilities. Storage optimization becomes achievable through different retention policies, keeping summaries longer than raw data to balance storage costs with analytical needs. Finally, gap management is crucial for data integrity. Use the fill summary index.py script whenever you need to backfill missing data periods to maintain complete historical coverage.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.